Hello everyone. Today we will learn about the relevant knowledge of geothermal power generation technology. Geothermal energy, in short, refers to the heat stored inside the earth. This thermal energy mainly comes from the heat generated by the decay of radioactive elements inside the earth, as well as the heat released by the geological processes such as the movement of tectonic plates and magma activity. According to the International Energy Agency, the potential of global geothermal resources is enormous, with the potential for geothermal power generation alone reaching trillions of kilowatt-hours, which is several times the global electricity demand. In China, the recoverable reserve of geothermal resources are equivalent to billions of tons of standard coal, with a huge development value. Geothermal resources are mainly divided into 5 forms based on their occurrence and temperature range: hot water type, dry steam type, ground pressure type, and hard rock type, and magmatic type. Each form of geothermal resources has different characteristics, reserves, and difficulty in development and utilization. 1. Hot water geothermal resources, which are the most common type of geothermal resources, refer to the thermal energy stored in the underground hot water. The temperature of this hot water is generally above 90 degrees, and they have high development and utilization value. Hot water geothermal resources have abundant reserves and relatively mature development technology, so they have been widely used worldwide. 2. Dry steam geothermal resources refer to the steam directly emitted from underground, with a high temperature which usually exceeds 150 degrees. This type of resource is relatively rare, but has extremely high development and utilization value. Dry steam can be directly used for power generation with high efficiency but limited reserve, making development and utilization difficult. 3. Ground pressure geothermal resources. It utilizes the pressure difference of high-pressure hot water or steam underground for power generation. Ground pressure geothermal resources have large reserves, but their development technology is complex and requires a high level of engineering technology. 4. Dry hard rock type geothermal resources refer to high-temperature rock body located deep underground, with temperatures generally exceeding 200 degrees. Dry hard rock type geothermal resources have huge reserves, but their development and utilization are also difficult, requiring special engineering techniques for extraction and utilization. 5. Magma type geothermal resources directly utilize the thermal energy of magma inside the earth. Magma-type geothermal resources have extremely high temperatures, but their reserves are limited and difficult to access, making their development and utilization extremely difficult. Currently, they are still in the research and exploration stage. Next, let's understand the basic principle of geothermal power generation technology. Geothermal power generation is the process of converting the geothermal resources into the electricity. Based on the types and the characteristics of geothermal resources, taking hot water geothermal power generation system as an example, there are mainly two forms: flash geothermal power generation system and binary cycle geothermal power generation system. The flash geothermal power generation system is mainly suitable for the high temperature and high pressure dry steam or hot water geothermal resources. Its working principle is to directly introduce the high temperature and high pressure steam or hot water extracted from underground into the flash evaporator, and reduce the pressure to quickly vaporize water to produce steam, driving the turbine to generate electricity. The flash geothermal power generation system has the characteristics of simple structure and high efficiency, but requires the geothermal resources to have high temperature and pressure. The binary cycle geothermal power generation system is suitable for geothermal resources with lower temperatures. The system consists of two circulation circuits. The geothermal fluid in the first circuit transfers the heat to the working media in the second circuit through a heat exchanger. The working media is heated and evaporates to produce steam, which drives the turbine to generate electricity. The binary cycle geothermal power generation system has lower requirement for the temperature and pressure of geothermal resources and a wider range of application, but the system structure is relatively complex and the efficiency is slightly lower. Geothermal power generation as a clean and sustainable method for energy utilization has a broad development prospects. With the advancement of technology and reduction of cost, the application scope of geothermal power generation will continue to expand from power production to urban heating, agricultural greenhouses, and other fields, all of which have broad development prospects. Geothermal power generation is an efficient and environmentally friendly method for energy utilization, so we should strengthen the exploration and development of geothermal energy resources, promote the innovation and application of geothermal power generation technology, and contribute to the construction of a clean, low carbon, and sustainable energy system. Thank you.